Now we will resume the seminar for the session 3. And for the third session, we have two presentations ready. And as a moderator, we have Professor Hee Sung-yoon from Korea Maritime and Ocean University. Please welcome him with a warm round of applause. Yes, finally, we are at almost the end of the seminar, the session 3. The topic is future cargo transport via Northern Sea route. I believe we will have a lot of insights from the presentations ready. We have 15 minutes dedicated for the session, so I believe we have two presentations, 20 minutes each. Then we will have a quick Q&A. And we now start at 5:05, and I hope we can wrap up by 5:55. So in the session 3, we will address more specific issues. So the first presentation is about shipping cars across the Arctic, the potential for pure car carriers using the Northern Sea route. That will be presented by Professor Michael Acciaro from the CUNY Logistics University, Germany. And the second presentation will be delivered by Mr. Dong Lee from Unico Logistics Korea under the topic of what is optimal cargo for TSR and NSR. Okay, then let me invite the first speaker, CUNY Logistics University, Professor Michael Acciaro. Please, Professor.
Hello, my name is Michele Acciaro. I'm the director of the Hapag-Lloyd Center for Shipping and Global Logistics and associate professor for maritime logistics at the CUNY Logistics University in Hamburg. I would like to thank the Institute for Arctic Logistics of Yongsan University for the kind invitation to speak at the 9th International Arctic Shipping Seminar. Of course, I would like also to thank the host, the Korean Ministry for Oceans and Fisheries, and the Busan Port Authority as a sponsor of the event. It would have been a great pleasure to come to Korea and to Busan in particular, where I have never been. But of course, we'll have to wait for better times when we will be able again to travel internationally. I would like in particular to thank Professor Sung-Won Hong for the suggestion to prepare a presentation on pure carriers and Arctic shipping, as this is an area that I was really interested in exploring. A large part of my background is in container shipping, and of course looking at pure car carriers requires having a different view on this sector. So thanks a lot for this opportunity, and I'm looking forward to hearing also of the rest of the symposium and the other participants, what are the current developments when it comes down to logistics through the Arctic. Obviously, cars are an important product being traded between North and East Asia and Europe. The European car manufacturers estimated in 2019 that Europe exported about 500,000 motor vehicles to China, and half of that to Japan, and 175,000 to South Korea. And Europeans also imported 762,000 vehicles from Japan, about 500,000 from South Korea, and an increasing market also from China with 250,000 motor vehicles. This results, according to a study published in 2015, to about 1 million tons of potential car trade between Northern East Asia and Europe. The great advantage of this trade is, of course, linked to the shorter distance. If we look, for example, moving cargo from Yokohama to Europe would result, if the Northern Sea route was used, in a reduction of 40% with respect to the Suez Canal. And similar benefits are obtainable also from other ports globally. These are, of course, reflected not only in the distance, but also in a substantial reduction in transit times, where we would have a difference of several days when the Northern Sea route was being used. The business case for the Northern Sea route is quite clear. If you look in the map on the right, which has been developed in a study published by ECORES that was carried out for the European Commission in 2019, and that was presented at the Hamburg Symposium on Arctic Shipping last June 2019 of last year, we see that the 35% reduction in route length also results in a substantial reduction in fuel. Now, the ECRI study was focusing on container, so we had to adapt some of those figures to the pure car carriers. And to do this, I use a study that was published in 2016, which used as a reference a vessel built in 2018 with a capacity of 6,500 car equivalent unit and a design speed of 20 knots. Obviously, it would not be possible for such a vessel to sail at full speed, so we would have to reduce the speed to 15 knots. In some cases, some argue that 16 knots could also be reasonable for the Arctic, but we will use two alternatives throughout this presentation, 16 knots and 18 knots. They result for one single voyage into a fuel consumption of 652 tons of fuel, or 838 if the vessel goes a little bit faster. That compares with the Southern Sea route through the Suez Canal and of course the Malacca Strait with the similar speeds to instead 998 tons of fuel and 1,279 tons, which is actually quite substantial. This, of course, also needs to be compared to the price. We are at the moment relatively low price, so I've taken a very low sulfur fuel oil price average, global average of 377 US dollars per ton. This is, of course, an average which is a little higher of what would be the bunkering prices in Rotterdam or, for example, in Singapore. But considering that fuel prices are very low and have been very low in the last few years, this could be a good approximation. Now, this would generate savings. So moving from the Southern Sea route to the Northern Sea route would generate savings, depending on the speed, between 129,000 US dollars per voyage up to 166,000 US dollars per voyage. Of course, would be reflected in a car equivalent unit, in a saving per car equivalent unit between $19.8 and $25.5. Now, this, of course, seems to indicate that the Northern Sea route is a clear winner, as the savings are really substantial. In reality, things are a little bit more complex because navigation through the Arctic is very dangerous and difficult. And for all liner trades, including car trades, reliability is a very important parameter. And because of the inability of sailing on a regular schedule all year round, and as well as the potential risks associated with weather, but also environmental and safety risks, we have to consider that the reliability of this route is much more limited. On top of this, of course, we have also a very complex geopolitical situation and a lot of uncertain economic benefits. These benefits are related to the logistics. The logistics is generally not a point-to-point, although, of course, for car carriers, we can consider as relevant movements from one port to the other. But of course, we would have to consider what the consequence for the logistics chain would be. And we also have to consider various constraints in terms of navigability. For example, the depth. The Lepta Straits is notoriously very shallow, and there are other points in the Northern Sea route which are relatively shallow. On top of that, we also have to consider the weather conditions. If it's true that on the one side, climate change has allowed us to have more availability of the Northern Sea route, or to have the Northern Sea route navigable for a longer period of time and for a longer summer, it is also true that climate change has also been causing much more extreme weather events that for car carriers are very, very important. And on top of that, we also have to consider the lower fuel prices and the excess capacity that make, of course, risky investments much less attractive. Also considering that in order to sail through the Arctic, we will need to develop ships with at least some ice conditions to be able to extend the navigability for a longer period of time, and in order to avoid risks of accidents. Now, let's have a look at a more realistic calculation, starting with capital cost. And in order to do this, I take an example of a MV Taos leader. This is a ship which has been bought and built in 2015. It's bought by, or is owned by Singapore Shipping Corporation and has been chartered on a long-term charter to NYK. The reported purchase price from the press was about 80 million. That was reported in 2014, and the estimated charter price was 10.8 million for 15 years. Obviously, this is not an ice class vessel, so we have to consider that if the vessel was to be transformed or had been from its construction an ice class vessel, we would have an increase in the cost of the vessel. That would be 10 to 40%. So that would result, assuming a conservative 25% cost increase for simplicity, in about 100 million. We would also, of course, have to consider that the owner would expect to also have a similar premium on the charter price, and that would be, of course, if we consider a 25%, an increase that will come to 13.5 million charter price per year. Of course, these are assumptions, but I think they could be considered relatively realistic. Now, what would happen once we have the cost per year? We need also to evaluate how many trips could a vessel do throughout the year, and how many trips more we would be able to do through the Northern Sea route. In order to do this, we need to calculate what would be the transit time. You can see on the left-hand side, we calculated that for different speeds. Obviously, if we go faster, we have shorter transit time. If we go slower with 15 knots, we have longer transit time. And that results in the Northern Sea route a case between 17 days and 20.5 days, while in the case of a navigation through the Suez Canal, that would result in 26 days or 31 days. We also have to consider that the vessel cannot operate 365 days. I'm taking aside in this case maintenance and accidents and any sort of type of disruptions to keep the calculation simple. We also need to consider the loading and unloading that is in these vessels is important, and it's very time consuming. And I use for this the estimation provided by Zhang in a paper published in 2013, and reference to all this literature at the end of the presentation that will be made available to the participants in the seminar. Would results approximately in 27 seconds per car. That means for a ship like the Taos leader, that would result, which carries 7,070 car equivalent unit, that would result approximately in 53 hours. And then we can consider 3 days just to round out berthing and getting inside the port, etc. So that will give us, in terms of transit time, would allow us to calculate the total number of trips that these vessels could do throughout the year. In the case of the Northern Sea route, this would be between 18.25 and 15.5 trips per year. In the case of the Southern Sea route, so through Suez, that would be between 12.5 and 10.7. These are again approximation. We would have to consider the availability of icebreakers in the Northern Sea route and the ability to transit through the Suez Canal. But again, these are rough estimation to get a rough calculations. Also, very important, we have to consider that these trips are one way. So it would be necessary to find enough cargo on both ways. But especially from these routes, from the statistics that I've indicated, this seems to be a relatively balanced route. Although obviously there are more cars being imported to Europe than being exported from Europe. And so that would also be taken into consideration for a real cost-benefit analysis. Now, assuming the maximum possible loading, we can come, and assuming, of course, that each trip is being carried out with a full load, this will come, depending on the speed, to a transportation of just above 100,000 car equivalent unit, between 109,000 to be precise and 129,000 for the Northern Sea route, and instead a much more modest 75,000 up to 88,000 for the Suez Canal. Of course, we have to consider that the Northern Sea route is generally not accessible all year round, so we would have to consider different scenarios. I followed here a tradition in a lot of those papers and developed and suggested 3 different scenarios. You see here a calculation of the output for the scenario where we have accessibility for 12 months, accessibility for 6 months, and accessibility for 4 months. And in the table, you can see the calculations that are a weighted average of the availability of the routes, which would result, in the case of a 15 knots ship, into something that ranges between, in terms of output, of 109 car equivalent unit, in the case in which the Northern Sea route is used a full-time, full year, down to 86,000, almost 87,000 car equivalent units if we were sailing only for 4 months. And at the same time, we have, of course, in the case of a faster speed, 18 knots, that we would be ranging between 129,000 car equivalent unit down to about 100,000. So as you can see, the output is could be quite substantial, even in a system where we are not able to use the Northern Sea route full time. Of course, not using the Northern Sea route all year round implies that we have an increasing cost in the vessel, because of course the vessels that we would be operating is an ice class vessels that obviously would have also in principle not only higher capital cost, but also higher fuel consumptions. I have not considered the differences in terms of fuel consumption in this case, but even without doing that, that might be a small difference, and of course that will also require to consider the changes in terms of fuel prices. That gives in principle an advantage. These are the calculations that I've done for the 3 scenarios, and on the right hand side, on the column on the right hand side, the route through Suez. You see here in the first row the differences in terms of the cost of the ship, which is of course lower. This is of course the chartering cost, and you also see the difference in fuel consumption, and we can also see here the difference cost in total fuel consumed. So you can see that obviously the Northern Sea route will result in a lower fuel consumption, primarily as a result of the lower distance, so the 35% lower distance. We also have differences in terms of crew. I have tried to apportion those depending on the time in which the crew is sailing through the Northern Sea route, assuming that more crew is necessary in the case of the Northern Sea route. And I use for this the same assumption that Lazer has used in the 2016 study. And we have, of course, differences in insurance and maintenance, although they are not that substantial. Very critical in this analysis are also the transit fee that are charged by Russian authorities, primarily for the use of icebreakers, and the use of icebreaker is compulsory. And you see that these figures are very substantial, and they tend to decrease as we use less the Northern Sea route. They are proportional to the number of transits. Of course, we also have costs associated with the Suez Canal. These are numbered by transit, and I apportion them also depending on how much, of course, the vessel is sailing through the Suez and through the Northern Sea route. And then, of course, we have the difference in output that were calculated before. And you can see that in the case of a full use of a Northern Sea route, we have actually an advantage of, with respect to a Suez Canal, of about 7%. And in the case of a higher speed, of almost 10%. This advantage, though, is lost quite rapidly, because in case we are not able to use the ice class vessel all year around. And you could see, though, that with these figures we are almost have similar advantages with compared to the Suez Canal. But of course that does not compensate for the very much higher risk that we have associated with the Northern Sea route. So if you see in this summary, I put here a picture of a Russian icebreaker that is necessary for the sailing, and we can see that the reductions we have are in the range of a 1 digit, and actually probably much more modest. And of course we could argue that since the icebreaker fees are one of the major drivers, and it is likely that these fees are negotiable, I use in this case the same assumption used by Lazer of $38. They're actually 1,048 ruble per ton of cargo. And I've also assumed in this case that the Russian authorities would actually charge the cars by weight, assuming a weight per car of 1.6 tons per car equivalent unit. Of course, it could also be possible that the Russian authorities would charge a ship by deadweight ton, so the carrying capacity, in which case we would actually have a 4 times higher cost. In this case, of course, we would have to have a much more substantial reduction in the fees per ton to actually make this a valid option. Now, the current state of the pure car carrier segments is not very encouraging. So if you see, these are the development of the pure car carriers, we see that the fleet has not been growing very fast, and actually a large portion of the fleet has been demolished, as it can be shown by these diagrams here, indicating that the segments is not very healthy at the moment. So we have observed very low freight rates, and although the industry has really tried to rationalize, still there is a lot of risk that make an investment, especially a risky investment, such as in a ICE class car carrier, very unlikely. We have, of course, geopolitical and trade tensions, we have social unrest, we have recurring climate-related natural disasters, and of course, a lot of risk associated with the COVID-19 crisis. So the business in this case is very conservative, and we have seen that the only new vessels that have been built were those that were associated or backed with car manufacturers, such as the NYK purchase last year of 2 car carriers, new car carriers backed by Toyota. But this has also resulted in cancellation. Last year we had a CM Ashanti cancellation where the vessel was almost completed. The sailing conditions in the Arctic are extreme. Vessel needs to be adapted to these conditions. And of course, this depends on the typology of ice. We have, of course, young ice, but we also have old ice and ice ridges that make sailing very difficult. We have very complex navigation, and SOLAS and MARPOL. And of course, we also have country-specific regulation. And on top of this, we also have, of course, an enormous amount of risks which are associated with accident, the geography, but also the environment and stakeholders. So the current business case does not really seem to compensate for the very high risks associated with sailing through the Arctic. Through some email exchanges that I had with industries, I asked Wallenius Wilhelmsen, and they replied to me in the email that in view of the current and foreseeable commercial, technical, sustainability and operational considerations, Wallenius Wilhelmsen does not envisage the Northern Sea Route or Northwest Passage becoming viable for them. And so they do not see this as an opportunity. Other players I have spoken to, though, do see this as an opportunity. I've also spoken to the Port of Bremen, and for them, the risks of developing Arctic shipping, and especially in terms of investment, and they are active in Iceland with the Finnafjordur project, which originally was also, of course, associated with having connections through the Northern Sea Route, and Bremen is, of course, a very important car port. They also specified that for them, the environmental risks are too high. And even in their business plan for the Finnafjordur, they have tried to focus more on the local population and on green energy. So what is the future for the Arctic? I put here a picture, of course, of a gas carrier, because, of course, I think the Arctic has a much better business case for raw material extraction, as been already observed, but maybe also the growth in traffic driven by local development, mining, but also the development of local communities, which is a strong priority for Russia. Maybe also tourism and the occasional transit traffic. While for container, we might consider to have hub and spoke linkages, maybe taking advantage of maybe ice class or even navigation throughout the year in the Arctic with ice resistant, maybe even class vessels. And although there is a lot of uncertainty here, or where the hubs would be, whether it would be in North Scandinavia or maybe in the Sea of Okhotsk or in the Bering Sea, we do not have this possibility for pure car and truck carriers. So the outlook for this industry, in my view, remains relatively limited unless we have car manufacturers that are really willing to foot the bill of building these larger vessels and also taking the risk. And considering the relatively high reliability of moving cargo through Suez and the relatively low volume that are being transported, or at least the forecast for the relatively low volumes, I don't think that this will be happening in the near future. So I would like to thank you for this opportunity. I've put here the references to the presentation, and please feel free to contact me if you have any questions, and I'm looking forward to questions from the audience or further discussions.
Thank you very much for your, Professor Achara, thank you very much for your presentation. I thought about wrapping up your presentation or summarizing your presentation, but due to time constraints, let us move right on to the presentation to be delivered by Tom Lee of Int'l Logistics, and I will save some time for Q&A session. Good afternoon, ladies and gentlemen. I'm Tom Lee of Int'l Logistics. I'd like to go back to the previous slide. This is the agenda for my presentation. I will first start with the background of this presentation or this study. Then I would like to move on to the current EPC project in Russia, as well as some CIS project as a case study. And after that, I will briefly touch upon the competitiveness of the NSR. And I will also supplement that with some other case study with the example of the Ust-Luga project. And then I will conclude my presentation with some thoughts on how to improve the use of NSR. As I prepared this presentation material, I searched for some news articles. With the economic crisis triggered by the COVID-19, and despite this situation, the navigation via NSR has gone up in terms of the number of vessels, as well as the cargo volume. However, if you take a look at the dry cargo, the overall volume has gone down. Not just the MSC, Hapag-Lloyd, and Maersk, as well as other container carriers, are quite skeptical about the Northern Sea route. Well, I think some environmental factors have been in play in such a decision not to use the NSR. And with that in mind, what about the liquid cargo and dry cargo? What kind of dry cargo we can handle? I think EPC project cargo would be the most suitable cargo for the NSR. And although we do not have time to go through each and every detail, there is quite a number of projects going on in CIS area as well as Russia. It takes some time to move on to the next slide. And this is the first case study I'd like to share with you. And this is the case of Kazakhstan. It is located in the Central Asia. There are two potential routes here, and one is via Suez Canal and doing the inland transportation after that, or starting from Tallinn and using the River Canal and going through the Caspian Sea. And this is the most typical route. But given the location of the Kazakhstan, I think we can make the most of the NSR to have the shortest possible route. And that's the route we have identified and actually used for this project. And you can refer to the photos on the slide. We load the cargo on the crane, And if it's in the square form, then you can just load it, as you can see. But if it's in a circled shape, then you'd have to use this kind of a standing structure. And you would have to use a trailer custom made for this kind of cargo. So this is how we shipped and transported this shaped in circle shaped and round shaped cargo. And here, to compare the NSR and the traditional route, the transit time would be about 1 month shorter if you use NSR, and you can save some cost, and the fixed cost especially. Then it is easier for you to secure any vessels or equipment if you use the NSR. And offshore or onshore transportation is easier, and because you would go through a fewer number of borders, you can save some civil work. And to turn to some weaknesses, the first is that although there is a great number of plans, a navigational period is relatively short. It's available only in the summer, and because it's available only in the summer, yeah, there is a possibility of congestion in landing or arranging an icebreaker. So the availability of icebreakers can pose some potential risks as well. And as you can see on the right side of this slide, if you go inside of the country, then you can create this kind of an anchorage in a relatively easy way, minimizing the environmental impact. So you can do this kind of a waterborne transportation closest possible to the destination to minimize any kind of environmental impact. So this is another project case in Ust-Luga, which is quite close to St. Petersburg. Its location is quite interesting. First, you go through the NSR, and as for the oversized bulk cargo, you can use the NSR. And as you do the project, you might have some urgent need for delivery. In this case, well, you can use TSR. And as for a planned dry cargo, you can use a container carrier to go through a Suez Canal. So 3 different routes are available to the site. And we identified the need for coordination. So we came up with an idea of a forwarding company. I'm not here to promote my company or do some advertising for this company, but this is a company that encompasses all different types of transportation. Well, as a one-point contact or the contact point for all these modes of transportation, then we can do the coordination. Not just that, we get an investment from the DP World, and so this is the company which actually sponsors one of the most famous golf tournaments, where our Korean player is playing and expected to win. And this deal has been almost completed, and by next year we will see a complete integration between the two companies. And another aspect I'd like to highlight is that DP World has agreed to jointly implement a project for integrated development of the NSR in partnership with the Russian Direct Investment Fund, as well as the Rosatom and Norilsk Nickel. So based on all these facts, in developing the Northern Sea route, with whom should you form partnership? I think, well, forwarding company can serve as an enabler, because it is a project specialist. In addition to that, we have an ocean specialist, and it has the capability to run the PSR as the one contact point or coordinator. Forwarding company can be a great enabler. So if we can fully utilize a forwarding company, that would be the most effective and efficient way, which puts together the environment, logistics, and all different factors to ensure success. And the process would require a significant level of negotiation and collaboration and coordination. And the cooperation is the key among the stakeholders. If we can do all this, then we will be able to create some win-win solution for everyone involved with regard to the NSR. A lot of topics have been covered and addressed, and I'm the last speaker, and due to time constraint, I try to be very brief and to the point. I'm very glad that I can finish my presentation on time. Thank you very much.
Well, once again, thank you very much, Mr. Lee, for your presentation. In the first presentation, Professor Achero talked about pure car carrier, potential of operation of pure car carriers in the Northern Sea route. He also shared with us some data and comparison and analysis on the capex and operational related costs, and to come up with, the outlook on the economic feasibility. So he also shared with a conclusion. Yes, it's quite complex, the current situation we have. There are many risks involved and uncertainties, including environmental concerns. Yet, still there is the possibility of a growth in certain aspects. And the second presentation talked about the project cargo. So the key point here is that because it's based on multimodal, as a logistics integrator for forwarders, there will be a big role to be played. So that is the significance of project cargo. Okay, now we have some time left for questions and answers from the floor. If you have questions, please raise your hand. And here, if you, as shown on the screen, we have the participants connected online. Also, if you have questions, please raise your hand so that I can take questions. It doesn't really matter, questions, comments. It can be either to one of the speakers or to the participants. Please feel free to, ask questions. Well, it doesn't have to be, only limited to this session. Throughout the seminar, if you have any, issues you'd like to clarify, comment on, so we have some time left. So this is a really valuable moment for you, for all of us, to share really insightful, ideas amongst us.
Hello. Do you hear me? Yeah, thank you. Good morning from Norway and good evening in Korea. I have a question to this session panelists, but probably also to speakers from other sessions. When you speak about environmental considerations and concerns, what basically you mean? Because according to understanding of our institute, I hear myself. Yeah. Should I repeat what I told? Okay, sorry. So I would like that speakers elaborate a little bit on environmental concerns and considerations. Because if we compare, according to our knowledge of the institute that is doing environmental studies in the Arctic. We have more questions about Arctic environment compared to southern seas than answers. But then suddenly everybody talks about problems, kind of doing a parallels with the southern regions, while we do not. So could you define when you say about environmental concerns, what is basically meant? Thank you.
So your question is about environmental concerns and considerations. So is there anyone who can address this question among the speakers? So if there is anyone who can address this question, please proceed.
Thank you. I would like to relate, of course, and confirm what you are saying. There is a lot of unknowns, and unknown imposes, from a business perspective, a very big risk. So obviously, you don't have the same type of support that you might have in other regions of the world. In case, for example, of an oil spill or in case of an emergency, the situations are more dramatic, and therefore these can impose risks which are higher. Of course, I agree with you when these solutions could be improved over time, but they impose a very, very high risk on the operators. And the two I spoke to, but I understood from the chats we have on the panel that maybe Asian operators might have a different view. But with the CM operators that I spoke to and Valenius Wilhelmsen that I spoke to, for them, these uncertainties are a no-go, because the last thing that they want to do is, of course, run any risk. So even if potentially the risk could be controlled better, the fact that the unknowns are there and the very harsh environment imposes us to be very cautious. And also we have to consider that the Arctic, many areas of the Arctic are very vulnerable ecosystems, they are very pristine ecosystem. So as we have experience in other examples, the most known of which is the Exxon Valdez, when we have any accidents, and the Exxon Valdez was a relatively small oil spill, but if we have any accident in these areas, they attract an enormous attention from the side of the media. And I think for car carriers, I can speak, but I think also for container operators, this would impose an enormous reputational risk. And that's the reasons for which this environmental risk can be considered, even if unknown, much more relevant than what they would be in other regions.
Thank you very much. Okay, to Mr. Belkin, if you are still connected, because you are from the Russian, regulatory authorities, so I'd like to hear from.
Yes, I'm here, but I would like to just revise the question. The question was about the environmental issues while it's developing Arctic, if I'm not mistaken.
Yeah, I can specify, especially for you, Mikhail, possible. Because it was, as Michelle mentioned, more concerned about uncertainties. When we do not know from one side what environmental is and what are environmental problems, and from another side, how these problems can be fixed, then it creates wide uncertainty that business cannot take. And you are the one who is actually closing the gap on the side of response. So it would be very nice to hear your comment, how well you are prepared in case something happens.
Thank you very much for your question. I think ecology is the critical issue when you are doing any kind of development, especially industrial development. In our case, I would like to say that we are well prepared for, let's say, hope nothing will happen, but for potential technological disaster. But in any case, there is a big, let's say, big road ahead, because we see that currently the shipping on the NSA, and I'm going to speak only about shipping, if you don't mind, because this is my sphere of responsibility and expertise. I'm not talking about land-based facilities. When we are talking about shipping, currently we have a big, let's say, development, big increase in shipping that almost like a big bang. Less than, let's say, 5 years ago, we had 7 times less cargo flow through the NSA than we compared to what we're having now. And as I mentioned in my report, even the strategy of development of Arctic zone of Russian Federation says explicitly that the development, the economic development of the NSR is ahead of the infrastructural development, which we've got to close very fast because the cargo flow, the traffic through the NSR, and of course the number of vessels, big vessels, which are going through the NSR will be just increasing more and more. What I can say is that again, all the legislation which I mentioned, especially the new rules of navigation through the NSR, they are meant to avoid any issues which can lead to disasters. Those are the rules which which define what vessels can be used to navigate NSR, what ice class is required, and what support you need from the state-owned enterprise. Like, for example, in our case, icebreaking support. Then, again, in my report, there was a table which showed the development of icebreaking fleet, which is especially needed to provide which is needed to provide us braking support in the very first place and to let the vessels proceed through the ice infested waters without any problems and without the danger by ice and thus compound damage. Now we have a full-scale fleet of emergency response vessels under construction by the Ministry of Transportation. There are about 16 vessels which must be built by the year 2024. And they are specialized vessels for the Arctic navigation. Some of them are icebreakers, like Megalith. They're not atomic, they're conventional vessels. But they are specially equipped to combat potential illness, provide search and rescue operations for vessels in danger. So I would say that currently the state takes quite profound measures to make NSA safe and sound, and to be able to provide response to any potential dangerous situation or any emergency. So if this answers your question, this is all. If not, then ask further.
Yes, good. Thank you very much.
Excuse me, and I'm sorry, I could not hear the English translation. So could you return again, Karen?
You will make some comments on car carrier transportation. So now the floor is yours.
Okay, thank you. Well, thank you very much for very, very interesting presentation for all the panelists. And I was very interested in the pure car carrier idea scenarios. So, and maybe before the container transport, car carrier transport could be the one of the interesting and potential scenario to utilize the northern segment. However, the environmental issues is really, really important. And the heavy fuel oil ban is going to start 2024 if the IMO proposal is adopted. So anyway, the shipping sector who try to use the northern sea route must be considered about the more seriously to use the fuels and also other environmental protection issues. Thank you very much.
Thank you very much. I'd like to thank all the speakers and the panelists for session 3. And this concludes session 3. Then I'd like to hand the microphone over to the MC of the whole program. Thank you very much for your avid participation. I'd like to thank Professor Yoon for moderating this session. This concludes the 9th International Arctic Shipping Seminar. Before we close, I'd like to make some comments. I'd like to ask for your understanding for the poor connection, internet connection this morning and the poor quality of the video, although it was not aired and streamed via YouTube. Everything is recorded on the Zoom platform. So if you visit the YouTube channel of Arctic Shipping Institute of Arctic Shipping and Logistics, and then you can take a look at the video recorded. And I'd like to show you the website of this seminar. All the presentation materials will be uploaded on our seminar's official website. I'm sorry it takes some time. So all the presentation files will be uploaded on the website. So all of those who join us virtually can pay a visit to our seminar website to get the presentation files. And by 6 o'clock, if you send an email to our research center's website, then you will get the full color booklet of the presentation materials via email. It's because it's full color, it will be much easier for you to understand all the materials and the content. So once again, thank you very much for staying with us till the end of the 9th International Arctic Shipping Seminar. Thank you for staying with us. Thank you very much.